Okay, I need to share my screen. Okay, so I try to make it clear for the guy. Few things. First thing on the quiz of the electronic. Okay, if you can do it, that'd be good. Let's just try to make sure uh, to guarantee you still memorize what you learn. Okay, for the tech one, you just learning the basic. If you see the diode or you see the JFET, you can know right away how they working. That's good for your if you need to get the interview for your job. Okay, so I try to make sure you're able to keep continuing. Okay, on that quiz. Now on the DLAB, that requirement. The thing in the textual really complicated for the student. Some students, they already get the certificate ready, but they still want to learn. Okay? Only thing is if you not get your certificate, then you must be done. The other student, I don't care. So the lab number 1 to 7, that's a simple lab. That means you can able to done for Excel when they pass you converting from port A, port B, port C, port D to the program. If you know how to follow exactly, then that will be make the test will be passed. However, from lab number 8 and so on later, the problem is different. Okay? Some not in the port A, B, C, D can help you to coding your program. To coding your program, you really have to understand. Okay? Now, this is a real job. For example, in the company, you have to run the test to test the circuitry. And if it fails, what your job will be fixed. Okay? That will be required troubleshooting. You understand, only this program can teach you the way real happen in the company. You can go college, university, never where they don't have this kind of program. Okay? This program only training for you to be a real technician. In company, you don't have to write the test program. And you only test and fix the circuit board. However, in this program, without using the software, then we cannot teach you. So that's why I help you maximum when you get a problem with your test program with the software. Okay? If you try to compile your program, you get an error. You just get in Zoom to me. Okay, with me. Just take a few minutes, will be correct that easy. Okay? Or anything with software we support the maximum for you. The thing is, did not at the company not require you to do. The program engineering already did it. You only testing. Okay? So from the number 8, the grade will be a different. Okay? So if you're looking into the schematic, how many IC will be using for this lab?
10.
How many IC?
10.
10. Okay? Easy, you can see what your number. 1, 2, 3, 4, 5, 6. Okay? Up to number, last number. That's telling you how many IC. In the company, they're not using A or B. However, in here, we're using A and B. Okay? Like U4, U5, U7A, U7B. That makes no difference. The thing is U7 is U7. Okay? And now, if you're looking for thing, you're looking into the lab. Okay? I want to see here first. Here, this is the one. Let's see, this is software now. This port A, B, C. I don't care that. Where is they telling you what the that number?
Were you looking for the functions, Mr. Pham?
No, not function. But they're talking about that one, that two, that three.
Yeah, test requirement document.
Right, PRD.
Yeah, should be just above that one, but your one don't have it.
I don't have it, right?
You don't have it there. You're missing that blank page.
Okay.
Oh, hang on.
Is that it? That's it. That's
right
it.
there. Yeah.
On the bottom, right there, right there, right there.
Now, this is, okay, that number 1, okay? This is the thing you really need. The test number 1, they telling you test U1, U2, U3 for data 55. Now, what you need to do is you see in the schematic, test number 1, they testing data, okay, 55. U1, U2, U3. Very simple thing. You understand first thing, relate to U1, U2, U3, right?
Right.
I already telling you. Now, see how they working. First thing you need to do at your job, then you have to go to the Google if you don't know, to looking for 74164. Try to see how they work. Now, in this one, I already telling you, 164, that means you get a serial data go to pin 1 and pin 2. And they will be converting to 8-bit parallel output. That's very simple. If you get 5-5, then you get 5-5 out with the parallel, and this is serial. If you get a AA or ending data, they get converting to 8-bit parallel, okay? And right in this program, you don't worry about how they doing inside. I don't care what inside here. Only thing if I say, I write to PA pin number 10X55, then I suppose to get, okay, 1010 here. That means 55. Or AA, then I can get a 101010. Okay, that is how that IC will be doing. So first thing they telling you write PA 0155, and they converting here parallel 55, and they go to the U2, okay, and they will be verified, make sure you can get 55. However, in order to get the U2 to get the input data go to the output data, pin 1 and 19 must be 0. And that will be coming out from U3, pin number 5. Okay?
Four.
Pin number 4. That means you have to make pin number 4 0. Then you can read it. Okay? So that is the first test. Now, in here, I already wrote something in here to help you out. I said, this test write serial data 55 to U1. Then you need to enable U2. Then you can verify a data. Okay? So, how can we enable U2?
If you want to enable U2, you need to make U3 pin 4 1.
Okay, now,
you mean to enable it, to make it work?
I want it to be 0. Then
If
this
you-
have to be 0. This
Yeah.
have to be 0.
Correct.
Right?
Right.
If you know that the U3 decoder, okay? So basically depending on A and B in here, A here, B here, 0, 0, the first low, 0, 1, second low, 1, 0, next low, 1, 1, the last low. Only one output low at a time. Okay? So, the way we want to do, you must be understand. If you want to send the data into U1, 55, then you must be using the function. Okay? That function will be called a serial data, whatever, we'll show you. That's the first one. Second one, if you want that to be 0 here, that means I call the function enable U2. So in the function, okay, we can say you can write this data, then you have to be enable U2. Now, this is a function definition. Okay? Enable U2. I want you to write in what data you're supposed to put in here into the port B. You know what the number?
0x00.
0, 0, 0. Okay, so that you done with the enable YouTube. So now on your test program, okay, the test number 1. Okay, first thing is you need to call the serial data. Okay, and data will be 0101. Then you say enable YouTube. If you want to verify, you're supposed to reading, proceed, compare, pass or fail. Now in here, I put into one function. That function do everything when you read it for you. Okay? So that is the test 1. And now, if you want to go to test number 2, then what you need to do is you have to change the test title, right? If you're reading on the handout, they want the data to be expect data. You sending AA, you supposed to be read AA. Math data, we don't need that, right? You not change the math data. And P-corp, you not change the P-corp. Then you can send the call the serial line, okay, function with the data 0x AA. You don't have to end, you need to enable YouTube and verify. So that means you first thing an easy one, you can set you test. I already upload the skeleton. Okay, that means the frame of this program for you. Okay, so when you download and upload it and then copy into your program, then you will be changing that. Now, first step, what you need to do is you have to be make this to be part. See
Mr.
that?
Fan,
Right now it failed. You have to enter the data in here.
Mr. Fan,
Yeah,
you know where you for the first one, okay? We have x0x00. Now on the top there, just above that line where say false is back, is comment out. This function was set u2-1 19 equals 0. What is 19 equals 0?
try here. That means I want that to be 0.
Yeah, it means that pins
Oh,
1 and
19.
19 of U2 go low.
Gotcha. Okay, that's 19
Okay.
over there. I didn't see 19 earlier.
Yeah.
Okay, thank you.
Hey, Mr. Pham,
Yeah,
yeah, I understand that. It's I just want trying to re-jog my memory. Okay, PB1 and PB2 are going to be 0, and PB3 and PB4 are really not needed. So that's the reason why you have the 0, 0, right?
yeah, we don't need it, we don't care.
Right. Right. Okay, you answered it.
Now, try to follow it, otherwise you can get lost. You cannot do it. First, next thing here, what I want to know, I want to enable U7A. They say they want to write to port B what the data. Okay.
0x01.
Okay, just a minute. Okay. I want to make sure we can help you guys. Okay. 8. Okay, now for the next function, 7a, one student says 08
01.
01. Okay, you guys, you know why 0801. You're looking into the schematic
Mhm.
here. Okay. When they go U7 pin number 1 right here, you're looking into U7. Pin number 1 right here. That means you want enable U7A pin number 1 must be 0. So that's why they're going back to number 1. That means pin number 5. So we already telling you, you get a 0, 0 pin for low. 0, 1. Okay. I get a B here, A here. 0, 0, 0, 1. 1, 0, 1, 1. So that will be go to U2. 1, 0, 1 will be U7A. 1, 0 will be U7B. And the last one not connect.
Right.
So that is why we get 08, 01 on port B. Okay. Enable 7B. What data?
0x02.
Perfect. Okay. Now, you want to looking into U4. What U4? What is U4 and how they working? U4 here. What is it? 160. You must be know 160 U4. That's a B, C, D counter. Okay. That means the counter will be counting up 0 to 9, then 0. If you read it on the data sheet, on the timing diagram, we already gave it to you. BCD counter, count up 0 to 9, then to 0. Now, then we have to know how many functions for this U4, okay, and how they work. The first function you can get, they can be the clear, active high, active low, sorry.
Well,
That means pin number 10 on the Q output ABCD must be 0. Highest priority. If pin number 1 is 0, you cannot counting. You cannot load it. Then the next function will be loading any number. Loading any number, that means you can apply input here, okay, A, B, C, D. And if the load 0, they will be go into the output. Okay, that's the second function. And the last function will be counting. That means counting up. Okay? So now you understand U4. So in the function area, I will be assign the function U4 for the clear. So when you call that function, they do everything for you. You clear the output to be 0. Then for the load, then I using a function name U for load. They do everything for loading number from input A, B, C, D to output QA, QB, QC, QD. And the last one will be counting up.
Hey,
Okay?
Mr. Pham, can you look at number U3, 10, and 11? I just want
U3.
10, 11. Okay, so,
And here,
yeah, okay, yeah, because you can only have 1 0 at a time. So then, yeah, you wouldn't be loading and clearing at the same time. I guess I answered my own question.
U4 you want to clear. Then pin U3, pin 11.
Yeah, because 11 for clear, 11 would be 0, and then 10 would be 1. Yeah, I think I answered my own question. Go ahead. Because there can only be 1 0 at a time.
Right.
Right. I got it. Okay, thanks.
Okay, so that's why if I'm looking in here, I say I want to test U4 clear. Okay, then I need the function U4 clear. Now we go back to the function. If you get a function done, that means almost a program done. But I require the understanding. Okay, now you load U4. And I already bring it up for you here. You have to write serial data to bit 1 data. That's the first thing function you have to call. Second function, second one you have to write to port B, what data? Write to port D, next data. And you have to using function U for clock. So that's why every time you call a load U4, what data you want, then a load U4 inside, you have to say 08505, you load number 5, or 0809, you load number 9. So my question is, what you doing to write to port B on that load U4?
0x0b.
Perfect. You know everything.
I wish.
You really understand. 0x0b. Now, what you need to write to port D?
Zero x00
Perfect.
to enable U3B.
Perfect. 0. Okay, now 0x0b. That means you have to go into your schematic. Right here. If you're looking in here, right now we deal with the function load, right? So you can say U for load. That means you want this to be 0. Now, same thing. A here, B here. You get a 0, the first will be 0. 0, 1, the next will be 0. And now you want this to be 1, 0. Output pin 10. You want it to be 0. Okay? So you have to get the data here. 0, 0, the first one, 0, 1, next one, 1, 0. Okay, so that means you can get the 1 here, right? Then the output here will be 0 right here.
Let me see, that says 0, 1 you got there. So 0, 1 would make Y1 low.
Now that's supposed to be 1, 0, right?
If you got it the way you got it there, 0, 1, that makes Y1 low, which means you would be clearing.
Is
Okay,
it right?
1, 0. That's the third one, which is load.
Okay, so you want load to be a 0. So input you must be pin 3, pin 4, port B have to be 1, 0.
Yeah, and then pin PB2 and PB1 have to both be 1s to make it 0x0B.
Okay, now this is not working yet until enable pin 15 must be 0.
Hey, Mr. Pham, just to jump in real quick, like Adam just said, when you be using like 1, 1, that's on say on U3A, that's because you want to occupy PB1 and PB2, and if you send them to Y3, that's not connected, so it won't affect anything, correct?
You're talking about U3 what, A?
Yeah, U3A.
And what one?
Pin 7, yeah. If you put
Yeah,
a 1,
that
if you
means
put
we don't use it.
exactly. So then that's your way of occupying, say, PB1 and PB2, but then when it goes to the output, it's not connected, so it won't affect anything.
Right.
Okay.
Okay, so that will be bring it up to you. We get the say the function load. Okay. Here. That you get a 0B, then you get a 0, 0. Now, the next one is a little harder. We call U for clock. So you understand one thing. The IC160, everything will be controlled by the clock signal. You want the clear, you want the load, you want the counting, you must get the clock signal. Okay? Without the clock, the output is not changing yet. So even you want to clear, they still have to get the clock signal. Now this one, they will be U3B. Okay, let's see. If you see right here, let's go to the clock of the U4 clock go where? Oh, okay. U4 clock go to N clock. That means the system clock. What happened to U10A? What is it?
U10A is on the bottom. That's a gate or something, isn't it?
Buffer.
Buffer.
Yeah. U10A means if the enable 0, then pin 2 will be equal to pin 1. Okay?
And
That
Mr.
will be just a buffer.
Yeah, that end clock you just described right there, it goes through negative, but since that's an inverter, it'll get flipped over to a positive, right?
Let's see. This is a clock will be a negative, right?
Yeah, that's a negative
There's
clock.
a bubble here not telling you changing the clock. You
Oh,
get the
I thought that
negative-
meant to flip it over and make it positive.
No,
Or it stays the same.
buffer. Whatever in, out, same thing. Not inverter. Oh, this is the inverter.
Yeah, that's a NOT gate. That's not a buffer.
Okay, sorry. This inverter, that's a NOT gate. Okay,
So it flips the clock over, right?
right.
Yeah, that's what I was talking about. Yeah.
Okay. So,
Mr. Pham,
yeah,
so that is a inverted buffer or only an inverter?
no, it's not buffer, that's inverter. I'm sorry.
Okay, thank you.
If you're reading 7404 inverter. Okay. Now, why we need that? We need a positive clock. However, the system don't have enough clock for you. They get the only P clock we already using here. So we get a second clock, we call an N clock. Then in order to get a positive clock on the other side, you need to go to the
Inverter.
That's it. So basically in here, if you see, I said, okay, I said what? U4 clock. So basically you just using in that function, just put it in N clock. That they will be okay. Now, you want to clear U4. They asking you, write to port B, write to port D, and you will be apply U4 clock function. Then you write to port D. So I want to know what the data you're supposed to do on clear U4 here. First data, what do you think? Write to port B.
0x07.
Yeah, you know everything, man.
He's got it on his Excel right in front of him. Way to go, Adam.
Hey, this is the only part I got through.
And now what you write to port D?
0x00.
Right? 0, 0. U4 clock, that's okay. You call that U4 clock function. And the last one,
0x01.
how come you get it?
That puts a positive at the enable for U3B, I believe it is, which disables U3B.
Okay? Now, I helping you so you can get that one part, okay? Now, I want to say a next function, load U5. Go back to the schematic. Go to U5. U5 input A, B, C, D, load right here. Basically, they're coming out from U1.
U39. Oh, I'm sorry.
U1 here, okay? Okay, they go to U5, right?
Right.
So if you want to loading data A or 5, then they must be coming from U1, the last 4 bit. You see, U1 they get a 8 bit. First 4 bit they connect to U4.
Right.
Last 4 bit they connect to U5.
Right.
Okay, so you want to loading, you have to call the function for serial. So they given you the function right here. Now,
And U39's got to be 0.
yeah, in order to load U39 must be 0. So you can see U39 right here. If you want it to be 0, how?
3 and 4 has got to be 1.
Okay, so now
PB
you understand, then you know this have to be 1,
1,
this have to be 0.
0.
So that makes that load, right?
Right.
So now a little make it clear, right? Okay, so we can go into here. Okay, load U5. If you call this function, if they want to load 0101 number 5, then that you call this function, you have to say data here equal 50550. That means this is the going down 5. If you want A, have to be A 0. So you understand on this, I see 4-bit, first 4-bit using for U4. The next 4-bit using for U5. That U5. And that for U4. Okay, now you write to port B. What data?
0x0f.
No, that's going to be, isn't that going to be where like, it's almost like a clock where you're going to have 0x01, then 0x00, then 0x01?
Now,
No. I'm wrong. Forget it.
right, then you want to load U5. If you're looking back here, I'm already telling you. You load U5 and have to be 1 here, right?
Right.
It must be 0.
Right.
So that will be output pin 9 will be 0. So you have to write to port B, okay? And this have to be 1 and 1.
So PB1 and PB2 can be 1s because they're insignificant, and then it'll be, as Adam said, 0x0f.
Okay, let's see, 0, I, okay, 0x, 0f. Some student cannot understand why 0x, 0f. I going back in here, I telling you. Now, this is the A and B right here. Pin 1, pin 2, 3 and 4. You want 3 and 4 to be 1, 1. So you
Hey,
can
Mr. Pham, sorry to interrupt. Your marker, when you're pointing to something, it's not on. So sometimes we're not seeing what you're pointing to. Make sure your marker's on so we can see what you're pointing to.
Okay. Now, I just said data port B 0x, 0f. 0f means you want that to be a 1. That to be a 1. 1, 1, right?
Right.
That to be F. Easy to understand on U3B. You want that to be 0. So that have to be 1 and 1. However, on this guy, okay, basically you don't want anything here to be 0. You see that?
Right.
So that's why I want this to be 0. The thing is they not connect, not screw up anything. The purpose is I want it to be a 1. This to be a 1 only. And I don't care on the U3A. So in order to get away from a problem, I set it to be 0 on pin not connect. So not screw up anything. That's why I get F. Also U3B, in order to get a 0 here, and pin 15 here must be 0. Okay? So now we can get right, let's say load here, right to put D 0H 0 0, right?
Yes.
And then after you enable that, and you need to disable, right?
Yes, sir.
So
0x0, 0x01.
0H 01, okay? That will be telling you pin number PD1. Now set it to 1 to disable. If clock. That's terrible. It's giving you a lot of things, will be very confusing. I try to the best, okay? Now, if you look in here, I redraw U3B. Let's see. Right now, U5 clock right here, okay? Okay. I try to clear this one first. This is the first time I try to upload using the PDF. So that's why I can run in my iPad. If it's not, we cannot run. Next thing, if I want to copy, try to see, okay? I want to copy this one. Copy. Now I go to the Y here, okay? Perfect. Ah, see that? I copy it not right, okay? That only thing we want, okay? We want this circuitry only. I explain how they working. Now, if I get a 1 here, what pin number 12? U3B.
It won't be working because if it's 1, then
Okay, anyway, that one here, that's the pin right here. They will be a 1, right? Okay, now, if you get a 1 here, what output here?
0.
0. Okay, then now I set this to be, this have to be 0, 0. Okay, so if I set this pin number 1 here, PD1, first thing equal 1. Now I set it to be equal 0. Okay, so if it's 0 here, what happened? This pin will be
0.
0.
0. Okay, so now this pin will be 0. And this one will be
1.
1, right? You see that?
Mm-hmm.
So before the 0, now they go to 1. Okay? Then I try put the 3 times. 0, 1 again. However, I want it to be 1. So when they 1, that means the output here will be 1 and the output here will be 0. So that's why you can get look like this will be the clock. 0 to 1. The reason why we have to using U3B to create the clock, the thing is, the test system, we only get 2 clock, and now we need more clock. That's why we have to using the software and the hardware to measure the clock. Okay, so if you go into just a minute, okay, you go into here on the function. Now let's see, U5 clock. So first thing, what you write to UB?
0x03.
0x let's see, U5 clock. 0x03. And you write to put the 3 times. 0x 01. 0x 00. Then 0x 01. That means when you call U5 clock, they given you the clock we already show you. This one, they given to you the clock like this one. Okay? So that is the function U5 clock. That's a harder part, okay? So no more. So if you enter everything we already given to you here, then they will be telling you, you will be part, okay? In here, I enter the data in H1 here. This still failed. The thing is, this is a PDF file, not Excel. So they cannot telling you part or fail.
Mr. Pham,
Yeah, go ahead.
you're saying the system have 1 positive clock, 1 negative clock, okay?
That's only one we get.
Right. But how come we cannot just apply the positive clock where it's coming in and go to 2 different chips?
Cannot. Why? The thing is that screw up on the U1. I understand what you're saying. Okay?
Mhm.
Right here. P clock here, right?
Right. P clock, negative
You
clock.
connect to here, and also you want to connect to the other one.
Right.
Okay? Then, basically, when you apply P clock, then whatever in the A and B of P1, they will be going to here. You don't want to screw up. You see that?
I don't quite understand. I mean, if you
Whatever you call this P clock, right?
right, pin 8, you put a clock in there.
Whatever here. Okay? They
P1,
will be
right.
going to the output here.
Right, correct.
So that will be screw up everything. You have to like going back to say what you want on the U1 pin 3 to 13.
Mhm.
That will be really confusing. Okay? And the better way is create another positive clock. That is normally we doing, engineering doing at work. Okay? If we run out of the clock, that's what we have to create the own clock inside the circuit board. Okay.
So, Mr. Pham, before you turn that, so basically you're saying like PA1 got is hooked to pin 1 and 2. So you put a bit in, say 0 or whatever. And for that 0 to go through, the clock's got to turn over 1 time. And then the next bit will be a 1, and then the clock's got to turn over. Then the next bit is 0, then the clock's got to turn, and it keeps doing it till it does it for 8 bits. And that's the reason for the positive clock. Is that correct?
Yeah, that 1 bit need 1 clock.
Mm-hmm.
And this function, they already telling, help you to do.
Okay, and one last thing. On the negative clock that you have right there and the positive clock right there, one of them you call a system clock. So which one is not like a system clock?
That's what we go in here. Right here. Okay. L5 clock. When you call that function, they will be applied clock to L5 pin 14.
But that's not a system clock.
Now, that's a clock I just give show you how to get.
You're using your data inputs to create a clock pulse.
Right.
Okay, all right.
That's what I show you here. How do I get that clock? So in order to get a clock, I want AB00, okay? Then I just apply PD, okay, 1, then 0, then 1. Let it go up, then going down, then going up. So that negative clock, I need to inverter to make it to be positive.
And U1 and U5 can't share a clock because U1's clock will allow the data at the input to appear at the output, but the output of U1 affects what the input of U5 is.
Yeah.
They're directly attached. So if you start having transitions of the U1 clock, you're going to change what the output is and thus change what your data is at U5.
Exactly.
Okay, thank you.
That's why you cannot share. That's really confusing.
I'm glad Adam got it down, so if I have a problem, I'll ask him.
Yeah, if you can help the others understand, that means you really understand it.
Well, I just don't understand the part for U1 and U10. I mean,
U1. Now, what the question on U1?
U1 on the clock and the U10, I mean, U10A on the clock. Because
U10A, we want the clock for what? For
U4.
U4. U4, they need a clock. U1
Right.
also, they need a clock.
Right.
And the same for U4. The input of U4 is determined by the output of U1, so they can't share the same clock.
Right, cannot.
Why can it not?
The thing is, if you apply the P clock, you change everything here.
And QA through QD go directly to the inputs of U4, so you would be
Right.
changing your data at U4 too.
Right.
So it would mess everything up.
Exactly.
So it is the N clock, the negative clock, once it go through U10A, it becomes positive, right? And since it's positive, and I think if I'm right, it's in phase with P clock, so the two are together in phase happening at the same time.
But they're controlled differently though. That's the point.
So both of them are going through at the same time positive, and the first one the P clock go to U1, then go to U4 with all the results. And the other one is at the same time going to U4, the positive going in.
But the different data. You want the loading data, you apply ABCD.
Right.
In U1.
Mm-hmm.
However, in order to load, you need the clock for this U4. Then you need the clock here. You cannot using this clock.
Yeah, they're two separate things, right?
Yeah,
Is it because the negative clock is a cycle behind or something like that?
when
It's
you
because
go,
you apply them at different times.
You are applying them at different time.
right, after you loading data already here,
Mm-hmm.
then you can apply the load to be 0. They're not working until they get a clock going.
Mm-hmm.
So that's a
Okay.
different time.
Okay.
Okay.
Yeah.
You cannot sharing the clock anyway.
Okay. Now, also, if you look at U1, QA, QB, QC, QD, when it come out, it is connected together with U2, A1, A2, A3, and A2, A3, A4, A5, right?
U4, 3, 4, 5, 6, right?
For,
Yeah,
No.
that's right.
no, I'm saying U1, when it come out,
Okay. 3 go to here.
no, stop. Go in the middle where you the wire connect to the U2 port 2.
U2
Pin,
here.
right, U2 pin 2
Right.
is connected together.
Right. Not go together. Okay. Pin here will be 3 go to pin 2.
Oh, this one is going the other way. Okay, I see it. Yeah, okay.
Okay. So basically the first thing I send 5 go here. I wrap it around here. I make sure I read 5 and AA. Guarantee U1 and U2 will be working.
Okay, yeah.
And simultaneously, the output of U1, 4 bits of that will show up at U4, and 4 bits of that will show up at U5 at the same time. But unless you're wanting to read it from there, you're not worried about that. You're only worried about U2 if you want to read port C from U2.
Right.
Mm.
Okay, now I can also last thing I'm telling you. How data go. If I say I write U1, data will be 0, 8, 5, 5. Then the data will be 5 will be let's
U1,
see 0,
1, 0, 1.
1, 0, 1, and that will be 0, 1, 0, 1. Okay, so when they write 0, 8, 5, 5, what happened to see what is the output? So the first one here, okay, they will be go into the first one here, okay, and they keep shifting down. So if you're looking into the output of this guy, and they will be look like reverted 1, 0, 1, 0, 1, 0, 1, 0. So this is a number here will be A, 1, 0. The thing is, this is the most significant bit. So that will be 1, 0, 1, 0. Okay. So when in our software, system software, so when you get a 0855, then they given to you 1 here, 0. Exactly what you want. If you say, I want here 5 AA, then they given you exactly AA you want. Okay? So when you say write 55, then the come out have to be 1, 0, 1, 0. The thing is we already can software, okay, to make it working the way output supposed to be. Not try to telling you exactly how they ship it. Okay? You want 55, you get 55. You want AA, you get AA. Now, if I say I given you example. I want data 0F. Okay? 0I, 0F. See what happened at the output. Output will be given to you 1 here, 1 here, 1 here, 1 here. And that will be 0. Okay? Now, the thing is 0F, that means most significant. They given you 1 here, 1 here, 1 here, 1 here. And 0 will be here. Okay? That means our software try to help you exactly what you want at the output. And now you say, okay, I don't want this number. I want 0, okay, A0. Now, when you're looking at the output, you can get 0, 0, 0, 0. A will be 1, 0, 1, 0. So that's why when you try to call the function and you want to verify the output here, you troubleshoot it, then you can do exactly like normal. A means 1, 0, 1, 0. 1, 0, 1, 0. So on this lab here, okay, this one will be talking next time. However, if you can do, okay, in the code here, I already given to you everything on the function prototype, okay? Then now what you need to do is you have to get your function definition for x1. In order to get a function definition, that's what you need. You need this one, okay? Void enable u2. I given to you here, that means the function definition. And then you create the void enable u7. You just write to port B. That's it. And keep going. Okay? This thing you're supposed to do for the function definition when we get a meeting next time. And also you can see on port A, B, C here, I say on for reference. Now you cannot using port A, B, C, A, B, okay, for your coding. No, that everything have to be using the function. However, for port C, you can see the test number 1, 2, 3, 4, 5 here, okay, and they already, you can follow it to coding on the port C, okay, but not A and B and D, okay, and you get the total 50 for tests. So try to understand how we can do when you're using the function. From now on, most of the tests will be using the function. When you say, I want to clear U4, then I need to call the function clear U4. And what we need to understand is what's going on in that function. How many things we have to do in order to clear U4. We don't have much time to test for the circuitry using PSPI anymore. The thing is, later on, PSPI don't have a library. Okay, and also you can see most of the test will be using the function. When I reading a function, I know what's going on. At work, then you must be understand when I say I want to loading U4, then you have to understand how signal going. First thing you say, loading data go to U4 and apply anything we need to get the output of U4. Now, in order to verify, and I say they go to U7 and go to PC 1, 2, 3, 4. So what I need to do is, in order for data here, go to here, I need to call the function will be called enable U7A. Instead, you have to apply one by one to make sure you get a 0 here. Then we combine to make sure you call the function enable U7A. They allow input here, go to output here. And that happened the same thing for this guy, U7B. When you call the function U7B, they allow what coming in here, go to the output here. A lot of work and a lot of confusion. But I hope next meeting, I want to see on this to be part. Okay? And also, if you can, go into your program writing for function definition for each function here. That's what I want to see next meeting. And if you get any confusing, anything you don't know how to do it, online with me, you can get Zoom to me, text to me. I can help you out. This is a real job. It's not easy. Okay? Any question? I don't think you get any question. The thing is you don't know.
Yep, that's right.
Okay, everybody copy off of Kumi's paper.
Update on this one. Man.
Okay? Whatever confusing, whatever you need help, just text to me. I can Zoom with you. Okay?
Okay. Thank you, Mr.
Okay.
Fang.
The
Thank you,
thing is,
Mr.
I
Pham.
want you to help your guy to be a really technician and also data engineering job also.
Oh,
Okay? Know where they can take your guy like we're doing here. Okay? Then good night.
Okay, good night.
Sam.
Yeah.